Like I said, with great power comes great responsibility, and here's where things start getting interesting. A pointer can be reassigned to another memory location very easily, almost too easily. In this example that I have for you, I have a memory diagram like we had before. This time I have added a new variable of average equals 55. There's the average, there's a block for it, and then 55. And notice, yes, I put something in between, just kind of give it some space here. Pointer number 2, int star, and notice, by the way, the star is this time closer to the int. The last one was kind of in the middle. Really doesn't matter position, as long as it's between this and the name of the pointer variable that you want. Equals the address. Note I'm not even saying ampersand. I'm so used to saying address of the variable. And that's what pointer 2 is. It's pointing to the address, which is happening 90,000,008. And then, again, it's not pointing at 55. The interesting part about this is that this star and this star that you see right here do not mean the same thing. When I have it set aside in equal, using the equal sign and the ampersand, this is the creation. A star is being used to denote that we are creating a pointer and setting it to a location. Anytime I use a star with that particular variable, I am what's called using dereferencing to pull the information from that location in order to display the actual value, which is 55. Now, how the heck does it do that? So first of all, let's just look at pointer 2. It's going to know that pointer 2 is a pointer, not because of the name, but because of the star in front. Okay, but it also knows that it's an integer pointer. So it knows that once it points to something, it knows it's going to have a block of 4 bytes that it really, really needs to look at. Now, pretend for one moment sum was a float, which is 8 bits or something of that nature. Probably off. Then that pointer would look at all 8 bytes of that setup to say, okay, I need to look at all that because I'm a double. I know that pointer's in int because we told it was an int. So notice, these have to match. A double pointer will not work with an integer variable because it's looking at too large or something of that nature. It has to be a one-to-one match on what you want to look at. Second part, we already know that from the previous example, if we just did pointer 2, see out pointer 2, it's just going to give us the address. Here's where the star after creation of the variable comes into place, or pointer variable. Star now says, okay, I want to access whatever pointer 2 is pointing at. I want to access the actual value that is now within that integer block of my pointer, which would be 55 and all of these items that are down here. That's how it knows to access, number 1, using the star after we've created it. And number 2, how does it know how much of a block to look at? I told it was an int. Average happens to be an int. It matches 1-to-1, which is good. And it knows to look at all 4 bytes to gather the information. That is your setup with a custom pointer and the craziness behind it. How pointers can go wrong. Here's the problem. My code from here on up hasn't changed a bit. It's from here down that I have to worry. Remember when I said after the initial creation of the pointer, anytime I use a star, it's going to say, hey, I want the value at the address for pointer number 2. And now, again, going from right to left, I'm assigning 111 to the value that the address pointer 2 is pointing to. So there's the address. Here's the value. I've now changed it to 111. You're probably going, okay, well, that was easy. Here's the bad part. What was the original name of the variable that held 111? Was average. Notice I did not use the word average to change the value of average. That's a problem. That's where we have to be careful because average should be the one or the variable that really changes the value. I overrode it using a pointer, and there is the problem. That's where the power and responsibility of a pointer comes into place. Now, there are things around that we can do. If we know a value is not going to change, we put a const in front of it. We have to be safe and secure about our about our pointers using const or some other terminology that we'll move down in the road here in this class about. But that's why pointers can go wrong. Here I changed the variable average. I didn't even use its name. That can be scary. So yes, all I'm doing is proving my point here on a couple of things, and I get into a little bit about arrays too. So heads up, that's coming up soon too. So in this, I create a very simple integer variable, and I'm creating a very simple integer array. First part is just denoting the value and then the address, and you'll see it here with our value of x is 10, and there's the address for that. By the way, if I run this again, I bet it'll be a different address, which I'll show here in a moment. But I'm getting into an array too, which you should have already been introduced to. If not, then talk with me and we'll have to change things up a little bit. But in the array, notice it's an integer array, and I have 10 items that are in it. But all I'm doing is basically doing a couple things. First, I am introducing the address of the array. And notice there's that ampersand and then the array. And notice it happens to be that wow, whatever. But I'm going to end it with the FEN0. I bring that to a point because, look, I display the exact same thing, but this time the index of 0 for that array. Notice these two are exactly the same, and that makes sense. It's the first one in the array, right? So bear with me. Now I go to 1. I'll be darned. It's almost the same thing, but it is 4 things different. Difference of 4 bytes. We've talked about that before, haven't we? Because it's an integer array, right? 4 bytes, and I'll be darned. Index number 2, it's 4 more bytes. So notice this is already mapping out the 4 bytes it is for every integer pointer that we have. Now remember, short is 2, and all the other ones are going to be slightly different. But here it's proving the point that we are able to access individual items within an array. But again, we're just looking at the address. But here's the overall setup in prime detail for your pointers. I'm back. Nothing's changed, but I reran it again. And notice, darn it, if the addresses change, it's always going to change because, again, a lot of things are happening behind the scenes. But again, the one thing that is constant, notice it's 4 different between every single integer in that array for the 4 bytes an integer will need.